functions, and those function is squeezed at some value a. Like for example, we have one function like this, the gx. Another function we have like this one. This is hx. And the third function we have like this. This is fx. Now all these three functions squeezes at x is equal to a. So if these three functions, we have fx less than equal to gx less than equal to hx in some interval x equals alpha and beta, except not excusing at x is equal to a. So dear students, I repeat, we have three functions, fx, gx and hx. These three functions are increasing function for all values of x belongs to interval alpha and beta and necessarily not at a. Then the limit of this function at neighborhood or in the neighborhood of the a, x tends to a, f of x is same as limit x tends to here a fx, this is second function is gx, and this is same as limit x tends to a, and that is hx. That limit is same. This is called sandwich theorem. Now the question based on this theorem are: number one, a very common question we have, that is to find the limit of x tends to infinity greatest integer value x divided by x. To find the limit of this function, we use sandwich theorem. According to this sandwich theorem, we know the greatest integer value x is always less than equal to x minus 1. This is x minus 1, always less than equal to greatest integer value, and this less than equal to here x. Now whenever we are to find the limit of that function, so we will change this function, dividing each term by x. X minus 1 divided by x less than equal to greatest integer value x divided by x. This is x upon x, which will come here 1. Now if you are to find the limit of this function at x is equal to infinity, so all these three functions will have the same limit. Okay, limit x tends to infinity greatest integer value divided by x is same as limit x tends to infinity, that is 1. Now this can be formulated as limit x tends to infinity 1 minus 1 upon x. So at some places you will see this way, and the limit x tends to infinity greatest integer value divided by x, and that is limit of this function will be 1. So that's why we always say limit of this function is here 1. We treat this as a formula also. Very common and interesting one more question we have, where we need to find the limit of x tends to here infinity, and that is log x upon x. So as you know students, here the value of log x, this function here it is 0 less than equal to here log x and less than equal to under root x, because that is always positive value, square root of the x here. So this square root of the negative number cannot be calculated. So whenever you will divide each term by x, you will get 0 by x. This is the one function. This is the log x upon x, and this will give us under root x divided by x. So further, this is the 0 less than equal to log x. These are the functions, students, only, and this can be written as root x. Now extend your limit, and this is x tends to infinity. So whenever you will extend here limit x tends to infinity, this is 0 less than equal to limit x tends to infinity, which is question, the function is the other function, and that is equal to, here limits are same as I said earlier, and here limit x tends to infinity 1 upon root x. Whenever you will substitute this limit, this will come 0, either from left side or from the right side. So we treat the another question this as a formula. Limit of this function is 0. Here one more question based on the sandwich theorem, very common. I am talking about these questions. These questions are very much common. Like very often children commit mistake over here. Limit x tends to 0 and the function is x square multiplied by sine 1 upon x. You know here, students, the value of sine, and if it is written as the mod, this value sine x is always between -1 to +1, this value. So you can say here sine 1 upon x is always less than equal to -1 or +1. Now here multiply both terms by x square minus x square multiplied by sine 1 upon x multiplied by x square. So whenever you will find the limit of all these functions at x tends to 0, this is minus x square, here this is minus x square, will be same as limit x square x tends to 0, x square into sine 1 upon x, and that is limit x tends to 0 x square. So whenever you will substitute x square here, so this will be here 0. So that's why we always use it as a formula, limit x tends to 0, x square into sine 1 upon x, that is 0. So students, I hope you will enjoy this. Thank you very much.